this problem is about minimum energy consumption. We have a mathematical model that explains the amount of energy used in a small town. The mathematical model is E of t equals to 2t squared minus 10t plus 14. E stands for the energy consumption. The independent variable t represents time in years since 2004. So when you solve an application problem and then the variable stands for time, you have to point out the initial time. So in this problem, the initial year is 2004. That means when t is equals to 0, the year is 2004. Why do I need to point this out? Because when you deal with time, you do not plug in the 2004, 2005, and 2006 into the mathematical model. So let's take a look at the problem. Calculate the energy saved in year 2004, 5, 6, and 13. Where is the amount of energy usage at its minimum? All right. Okay, so we have t equals to 0 that represents 2004, right? Okay, so to calculate the energy consumption, we have to plug in 0 to t. So that is 2 times 0 squared minus 10 times 0 plus 14. That is equals to 14. Don't worry about what the unit is. So energy consumption at 2004 is 14. All right, so what about 2005? So 2005, that is a year later, right? So that means t is equals to 1. So from 2004 to 2005, you add 1 to it. That means you have to add 1 from 0 to 1. So for 2005, you do not plug in the 2005. You don't do it like this. All right, you say t is equals to 1. So 2005, no. So that is E of 1, which is equals to 2 times 1 squared minus 10 times 1 plus 14. That is equals to 6. So the next year at 2005, the energy consumption is 6. How about 2006 and 2013? So t equals to, and then we have 2006. So from 4 to 6, you add 2 to it, right? So from 2004 to 2006, that is 2 years later. So that means from 0, you add 2 to it, then you get t equals to 2. That is 2 years after 2014. Then E of 2, that is equals to 2 times 2 squared minus 10 times 2 plus 14. That is equals to 2. So don't worry about what the unit is. So far, initially, the energy consumption was 14 and then 6 and then 2. And then how about 2013? So from 2004 to 2013, that is 9 years later, right? So we have to add 13. We have to add 9 to it. So 9 plus 4 is equals to 13. So 0 plus 9, that is t equals to 9. And then you have to find E of 9. So that is equals to 2 times 9 squared minus 10 times 9 plus 14. That is equals to 86. All right, so that answers all the question. How about the next one? When is the amount of energy used at its minimum? So how do you know that there is a minimum? So first of all, look at the math model. So we have 2t squared minus 10t plus 14. What is the leading coefficient? The leading coefficient means the coefficient right next to the t squared. So a is equals to 2. 2 is greater than 0. So since the leading coefficient is positive, that means the parabola opens up. When the parabola opens up, the vertex of the parabola is the minimum. But how do you find the location, the x and y coordinate of this minimum? It is very simple. So in the previous video regarding completing the square, I already proved that for quadratic functions, to find the minimum or maximum, you have to let x, in this case, which is t, because we used to let x be the independent variable. If you take a look at the model, t is the independent variable, right? So instead of using x, we will be using t in this problem. That is equals to negative b divided by 2a. So what is b? B is negative 10. And then what about c? C is the constant 14. All right, we have negative 10 divided by 2 times 2. So overall, we have 10 divided by 4, then t is equals to 2.5. So what is 2.5 mean? 2.5 means, so when t is equals to 0, we have a 2004, right? And then you add 2.5 to it, you have t equals to 2.5. So that is 2.5 years later. So you add 2.5 to it, then you have mid 2006, right? So mid 2006, at that time, the energy consumption is at its minimum. All right, then can you find the minimum for me? The answer is, of course. So we know that in the mid 2016, the energy consumption of this small town is at its minimum. And then to find the energy consumption, we have to plug in 2.5 to the linear, not linear model, to the quadratic model. So E of 2.5, that is equals to 2 times 2.5 squared minus 10 times 2.5 plus 14. So that is equals to 1.5. And then this is the minimum energy. And this took place in mid 2006. All right, that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, subscribe to my channel if you're on your way out. I will catch you all in the next lesson. Signing off for now.